second. Cannot see the inside means, Shruti. What do you mean by this? Okay, so again, I'll repeat before we start the recording. Please check the box invite. I've already sent yesterday. And you just need to sign up with the box. You don't need to pay anything for that. And it's with you with the lifetime access. Every day session recording will be given, just like yesterday we have already shared. And then, no, Saranya, this is not allowed to talk to other team members, right? This is like privacy we always follow. You can just talk to the host, to me directly. That's not allowed. Right. So, okay. So thing is very simple. Use box and then your videos and notes, videos, recordings, everything will be there only. Right. And I'll send a separate email also about the URLs of the box drive. And then just very simple. It will be there with the lifetime access after that. Okay. Okay. So I hope you are able to see my screen. Can anyone confirm? This is a simple page. Are you able to see that? Perfect. That's good. Yes. If you're not able to hear me, please check your audio settings, guys. Okay. It's perfectly fine from my side. Okay, great. So just a second. Let me just start the recording.
Recording in progress.
Okay, great. Now, if you have any questions about box, let's take after the session. Okay. So today, as we discussed yesterday, that we have to start our JavaScript sessions. We have to understand that, okay, what do you mean by JavaScript? What are the different basic things? The first thing that we have to install, right? Because now we have to start writing the basic code and everything. And later on, we talk about the JavaScript features and then TypeScript also, then playwright and all those things, right? So whenever it's required during the training, more and more installations, softwares we have to download. Accordingly, we will download. But today, we have to understand that what do you mean by JavaScript, how exactly it works. Very, very important for interview point of view also. I'll tell you what are the different interview questions will be there, because this is the language based interview questions. People will ask that, okay, how exactly JavaScript works in your system, in your laptop, and then tell me the architecture of the JavaScript. What do you mean by browser engine and all those things, right? So these are the things that obviously in the first session we have to cover it. Then only we will be able to think like, okay, how to optimize the code, how exactly JavaScript is running my code, how exactly JavaScript is, different from other languages and everything. So first of all, what do you mean by JavaScript, right? JavaScript is obviously a language, a programming language, a scripting language, I would say that, right? So especially it was actually designed for the browsers, right? So what happens, simple, let's see, if you really want to design any website, for example, if I really want to design any website, I can say, okay, yeah, simple, create some buttons, text fields, and some labels, images, and that's it. But this is simple HTML that I'm designing it. So HTML is what? HTML, you can say, is only to design the components, only to design the elements on the page. If I really want to design some look and feel, I really want to fill the color, I really wanted, okay, no, this particular text field, should be having the gray color, or should be the black color, or this is a height and width of that particular element, and this is a button color, right? This is how it should look like. So if I really want to add the look and feel in my website, then we use a CSS, like cascaded style sheet, combining with the HTML. But JavaScript will define what exactly the behavior of the application, the behavior of the web page. For example, let's see if I really want to click on a button. So this is a click event that I'm doing it on my web page. This is happening because of the JavaScript. If I say I really want to fill something in this particular text field, I really want to scroll up and scroll down, I really want to generate the JavaScript pop-up or something like this, I really want to, do the infinite scrolling on LinkedIn. All these behaviors, all these things are happening because of what? Because of the JavaScript, right? And these days, all the applications that you see, these are the what? Dynamic applications. Dynamic application means like things are getting very fast, things are getting changed. If you go to, let's say, crickinfo.com, Virat Kohli is playing, and then the scorecard is getting changed in every 5 seconds and every 10 seconds, right? So we cannot say that, okay, application will always show you the same result. What if tomorrow, let's say I'm searching for MacBook here, Right now, I'm getting only 3 results. Let's see, after 10 minutes, I might get 10 results over here. If you go to any e-commerce application or any Uber application, Zomato, Swiggy, anywhere, right? In any application, things, the data is so dynamic. Number of users are getting registered, number of products are getting displayed. I can do the payment and all those things. So the things are very dynamic. It's not like static that every time only 3 products will be displayed. Every time the fixed values will be displayed in my table. It's not like that. So any behavior, any actions that I really want to perform, JavaScript is responsible for that. No, Gautami, you have to check your audio settings. It's absolutely fine from my side. Okay. So that's why we have to understand that JavaScript is especially designed for the browser initially. But later on, obviously, JavaScript is now everywhere. People can use JavaScript for the front end also, like for designing the web pages. Number of frameworks are available in the market, right? Again, I want to confirm, just want to confirm someone is saying no sound. It's clear, guys. Sound is there. Voice is clear. Bhima Gowda Patel, please check your audio settings. It's absolutely perfect for everyone, for me as well. So please check your audio settings, guys. This is just a Zoom call, and it's not a fancy software. Everyone is using the same thing. So please make sure that, okay, your audio setting is clear. Okay, this is not from my side. Okay, so if you notice one thing that, okay, initially when the JavaScript was there in the picture, it was only designed for the browser. For example, you must have seen something like this. Have you seen something like this when we go to the inspect and then we go to the console and here we can write the JavaScript, right? So for example, let's see if I write x is equal to 10 and then I'm saying, okay, fine. What is the value of x? If I say x plus 20, now it's giving me 30. So this is what? This is a JavaScript. If I say, hey, I really want to generate one alert with something like this, right? So see, one pop-up is coming, one alert is coming with the OK button. So this is what? This is the JavaScript in the browser. And browser understands only JavaScript. Browser does not understand any other language. Browser says, okay, whatever the language that you are using it with the Playwright, with Selenium, Java, Python, or whatever, I understand only and only JavaScript. So all these tools which are available in the market, any language that you are using it, doesn't matter which tool that you are using. If you are using Selenium, if you are using Playwright or Cypress with Python, sorry, Selenium with Python, Selenium with Java, or Playwright with JavaScript, or anything that you are using it, ultimately they all will interact with the browser. And browser understands what? Browser understands only and only JavaScript. That's it. Java browser cannot understand any other language, right? So we will see, okay, later on when we design the architecture of the Playwright, how exactly when Playwright is sending the request to the server. Here we are writing the code and this entire code will be converted into the browser compatible JavaScript. That's why Playwright is able to click on this particular button. That's why Playwright is able to fill the value. That's why Playwright is able to scroll up, scroll down over here. Same thing with Selenium also, same thing with other automation tools as well. They don't understand, browser does not understand any other language other than JavaScript, right? But you tell me one thing, are you really going to design the framework here in the browser? No, right? We are not writing the code here in the browser. This is just, okay, fine, just to check, okay, yeah, this is working fine, the some script that I'm writing. I cannot create number of files and all those things here. And I'm not designing the web application. My target is that I really want to design something test automation related things. I want to write my code. I really want to use Playwright or some other tool in my laptop, in my system, right? So what happens? Every browser is having what? How exactly browser is interacting and executing the JavaScript? Every browser is having one special thing that is called browser engine, right? And that browser engine is also called the JavaScript engine. Can anyone tell me which JavaScript engine is used by Google Chrome? Just for knowledge point of view, if you are aware of it. Not ES6, right? Have you ever heard about the V8 engine? No, Chromium is not the engine, right? So every browser, tomorrow you talk about any specific browser which is available in the market. Let's see Google Chrome. Google Chrome uses JavaScript engine as V8, designed by Google. Mozilla Firefox is using SpiderMonkey. Remember these names. You must have heard about Gecko driver also, something like this in Selenium, right? Another name is Gecko, but actual name is SpiderMonkey, but it is marketed by Gecko with the name of Gecko. This is designed by Mozilla. So Firefox also says if you want to execute anything in the Firefox, we have a SpiderMonkey, which is already running inside the Firefox so that we can execute the JavaScript. Same thing for Google Chrome, V8 engine is available here, right? I'll tell you how exactly engine works. Same thing for Apple Safari. Apple Safari, remember, this is JavaScript core. Okay, this is also called Nitro. Nitro is also part of WebKit. Have you ever heard about WebKit? The WebKit engine. This is designed by Apple. So whenever you're running any application in the Apple Safari browser on the Mac machine, it uses JavaScript core over here, right? No, this is another name is Blink. Okay, the other name of V8 is also called Blink, but generally we call it with the V8 only here. So what exactly these engines are doing? These engines are helping me to execute the JavaScript code in the browser. So whenever any application is running in the browser, whenever I'm sending a request to the Playwright, okay, please click on this particular button. Who is doing it? Playwright is doing it or V8 engine is doing it? Actually, this is done by the V8 engine, not by the Playwright. Playwright work is just to send the request to the browser. And once the request is available with the browser, I say, hey, click on this MacBook Pro. So V8 engine is actually clicking on that particular button or link or whatever it's available here. So every browser will have its own engine here, right? If you remember Internet Explorer, they were using Chakra, okay, Chakra engine, Chakra JavaScript engine, which is like almost deprecated now. And then there are other open source tools available. I mean, browsers are available in the market like Opera, Samsung Internet, Brave browser, Arc browser, Opera browser. All these, they are using the V8 engine. V8 engine is a modern JavaScript engine or browser JavaScript engine is available in the market. Designed by whom? Designed by Google. So tomorrow, let's say I really want to create my own browser. Let's say Naveen browser, right? So which engine is the best browser for me? Which engine? It's like a V8 engine is best for me. And who provides this particular V8 engine, right? So this V8 engine is provided by the vendor. Who is the vendor? These other vendors are available like Google, Mozilla, Apple, and all those things. So Google actually created Google Chrome. So Google says, okay, fine. We have created this particular JavaScript engine to run the JavaScript inside the browser, in the browser. Someone wants to use, you can use it. Brave browser says or Opera browser says, okay, no, we don't want to develop a new engine. Can we use your V8 engine? Yes, we can use it. So these V8 engine is actually running inside the browser in your system, which is actually helping me to execute the JavaScript on the browser. So because of these JavaScript engine, yes, they all are open source. You don't need to pay for this, right? So exactly, Microsoft Edge browser also initially with the support of Google and Microsoft, they are using V8 over here. And you see that, okay, switched from Chakra. That's why if you remember Internet Explorer provided by Microsoft, they deprecated Internet Explorer and then completely a new browser is available from the Microsoft, which is the Edge browser. So they shifted from Chakra to V8 now. Okay, so people might ask you at a time of interview that which JavaScript engine is used by which browser. Okay, so remember these terms. It will be helpful for the interview point of view here. Okay, no, Chromium is just a team name. Chromium is a platform to design the browser, not for the JavaScript engine. Right? Now see this carefully. But these are the browser engines. Browser engine will work only for the browsers, right? Not for my system. If I'm writing my Visual Studio code here, let's see, whatever the code, if I'm writing it over here, who is executing this particular code? This is also JavaScript, right? Then, who is executing my JavaScript code, which is written in some file, let's see, .js file or somewhere? That is done by the Node.js, right? So always remember the browser is actually using these engines, which is already installed with the browser. So whenever we install Google Chrome in my system, in my Mac machine or Windows machine, that V8 engine is also coming along with that. So that is only for browser. But for the local development, for the writing the code here, let's say I really want to write in my Visual Studio code. This is the code, let's see, I have written some .js file, .ts file that I have written. Who will execute this particular file? This is not the browser, right? So then in that case, the Node.js will come into the picture. So Node.js will provide one environment for me. Node.js says, okay, I will help you out to design the code plus execution of the code also. Just like in Java, Who is responsible for executing the code? Have you ever heard about JDK, JRE, those things? Java runtime environment. Java runtime environment will provide, okay, now I can execute your Java program. I can compile your code, right? But same thing here in the JavaScript, Node will provide that particular environment here. Node says, okay, fine, we will give you this particular environment to execute your Java code, to compile your Java code, to run your Java code. Because obviously we are not using the browser, we are using the Visual Studio Code or whatever the things that we are using, any editor that we are using. So what is the most important thing for us to download? The first thing we have to download is Node.js. So that's why we always say download the Node.js, and Node.js will give you what? Node.js will give you the JavaScript environment. Okay, it will give you one environment to run, or it will say to design plus run the JavaScript code. Okay, and Node.js is what? Node.js is absolutely open source, free of cost. We have to download the Node.js first. So I'll show you how to download it, right? But then how exactly Node.js is working? And what do you mean by Node.js? So see, Node.js is a complete library. It's a kit, you can say, complete kit, you will get it. This kit says, okay, fine, we will give you n number of methods, classes, n number of modules, so many tools that we will also give it to you. Along with that, we will give you what? We will give you the V8 engine also, right? So V8 engine is also coming along with the Node.js when we download it, right? And then after that, these other tools will help me to write my code, to design my code, to, if any kind of, let's see, if I really want to write any method which is available in the Node.js, or if I really want to interact, let's see, with my file system, I really want to go to the C drive and D drive, I really want to interact with my operating system. All these things will be done by this particular tools provided by Node.js internally. Plus, V8 engine is helping me to design what? V8 engine is giving me that environment so that you can execute your runtime. You can execute your JavaScript over there. It is giving me some environment so that I can tell, okay, yeah, this is the problem with your code at the runtime. This is the problem. Okay, this is what is missing. I really want to generate the output and all those things. This V8 engine is actually responsible for that, right? So whenever someone is asking in the browser, for example, I'll take one reference of Chrome browser, which JavaScript engine we are using. This is also V8. This V8 engine is coming along with the Chrome browser, but this V8 engine will work only for the browser. I cannot use browser V8 engine for my Visual Studio Code, right? So let's see, for example, this is my Visual Studio Code, and here I'm writing one JavaScript file. So what we need exactly in my system? We need a Node.js library. We need to install the Node.js in my system. So any tool which is using JavaScript or Playwright, or sorry, JavaScript or the TypeScript, let's see, for example, Playwright. For example, let's see Cypress. For example, let's see WebDriver IO. For example, let's see any JavaScript based tool which is available in the market, we need the Node.js. Otherwise, we cannot use that particular tool, right? So Node.js also says, okay, fine, we will give you some number of tools along with the V8 engine. This is not the browser engine. This is a separate V8 engine. We will give it to you so that you can execute your JavaScript code, so that you can execute your JavaScript files and the programs. Okay, this is clear. So any studio code that you're writing, let's see, Visual Studio Code. Tomorrow I say, okay, no Eclipse. I'll say, okay, no, I want to use IntelliJ. And I really want to create one JavaScript project. I can do that. But they all need what? They all need Node.js here. Without Node.js, I cannot do it. No, Node.js is not a tool. I told you, right? Node.js is a kit. Along with that kit, we will get number of tools internally, plus the V8 engine also, we will get it. Okay, see, this is a funny name that they have given. This is not car engine. This is like actual V8 engine. Like it is designed by whom? V8 engine is designed by Google. So they have created, you can understand like this, they have created two versions, one V8 engine for the browser and one V8 engine they have created for the Node.js. Why Node.js we need? So that I can execute my code, which is written in my Visual Studio Code in my system. Okay. So we will see that, okay, how exactly V8 engine works now, then it will be more clear. Got it? Okay. So first of all, what we need? First of all, we need to install Node.js, right? No, in Selenium, it's not needed, right? In Selenium, you use Java. If you're using Selenium with JavaScript, then only you need Node.js. Node.js is only for JavaScript-based languages. If you're using Selenium with Python, you don't need Node.js here. Okay? Yes. Okay. So why in V8? Because V8 is designed by Google and it's very powerful, very popular in the market. So Node.js suggested that, okay, no, we are going to use V8, not the Spider Monkey. So you see that, okay, the popularity of V8 is used by almost all the browsers. So that's why Node.js is also using the V8 engine only, not other engines. Okay. Yes, you will get all these nodes. Don't worry about that. No, no, no. NPM is different. Let's not mix it. Let's not talk about NPM today. It's a different thing. So what you have to do, first you open your terminal. Terminal means open your command prompt. Simple. Doesn't matter Windows machine or Mac machine. There is no special configuration required. Okay. Laptop wise, you can use any laptop. And here, what you have to do, just check that, okay, do I have node in my system or not? So I simple write, see node minus v means version. Can you see some version is available here? It means in my system, node is available. If you see, okay, the command not found or no version is available or node is not available, it means we have to download the node here, right? I told you right yesterday why we need Visual Studio Code instead of Eclipse. Eclipse is not compatible with JavaScript much. Eclipse is especially designed for Java. Okay, so that's why we are going to use Visual Studio Code. Now see this. Just simple go to this particular Node.js download page. I'll share in the chat also. You can bookmark it. I give you all these notes, links, and everything later after the session as well. And then you have to download the latest version. You can just pick any suggestion. Let's see, this is the current version also, or some LTS means long-term support version also. You can download it, or version 23. See, I'm having 22 version. So you can download 23 also or 24 also. Here you can select it. And then you can just simple select your operating system from here. Either it is Windows, Mac, and then Linux or AIX. There is no difference, guys, in the Windows or Mac. It's like exactly same. Okay, if it is different, I would have already told you. I would already shared with my Windows machine as well. Okay, right now version doesn't matter. I would always advise whenever you are downloading any software, don't download the latest version, especially with the node and all those things. With the latest version is not used by publicly much, right? Because recently released. What if there is a bug? What if there is a glitch? What if there is a problem? So always download at least -1 or -2 version, right? So for example, let's say 23, 24, it's absolutely fine. See, in my case, which version is available? 22. So I'm happy with the 22 also. There is no big difference between 22 or 24, right? So it's really doesn't matter which version of you are using it. But it's not like, okay, let's see, 25 is available and then I'm downloading, 19th version or 18th version. No, at least -1, -2, -3 version, you can download it from here. So it's very simple. What will you do? Simple select whatever the operating system that you are having it. No, 18 is not fine. Please upgrade to 22, Suraj. Okay. And then 22 is absolutely fine. 21 is also fine. Doesn't matter here. And then select your operating system from here. And then which machine that you are having. I think all you guys are having 64-bit machine. Select this particular 64 machine and then download this particular .msi. Okay. If you're using the Mac machine, then simple Mac machine also, you can simple click on it and then install this .pkg file. If you're using some other, let's say Linux machine, I'm not sure you guys are using Linux or not, but if still you're using Linux machine, then you can download this .binary file, .exe file here. But simple click on Windows and then click on this .msi. So this .msi will be installed over here. And then after that, you just need to do what? You just need to click on it and then next, install the software and that's it. No need to configure, nothing. Same thing for if you're downloading, let's see, for the Mac machine, simple use this particular .pkg file and then .pkg file. You just need to click on next, install the software and that's it. And once it is installed, after that, what will you do? Close your terminal and then open it again and then check this particular node -v. Okay, node -v here. Whatever the version that you have downloaded, it will display over here. So can you guys do that? Simple. It's very straightforward. Simple download the node. because this is the first thing that we have to download. Then only Playwright, JavaScript, and other things will work, because I need Node in my system. It's very, very straightforward. Okay, still not able to do that? Just let me know after the session. That's what I'm saying. It's already having it. No need to install. Why are you like bothering about if you're already having it, right? So just ignore it. If you're already having 21, 22, 23, whatever, it means Node is already available in your system. It means maybe you are already doing the practice in your system. Okay, this is clear? Okay. Now, this node is available in my system now. After that, what we have to do? Rishikesh, we will check that. If you're not able to do for Windows, you can share your screen after the session. Okay. Okay. Then what is the next thing we have to do? Best thing to upgrade, always download the latest version from here. There are commands also to upgrade, but download the latest version, whatever the version that you are selecting, and then download it. It will override the previous version. Next thing is that we need to write somewhere, right? We need to write the code somewhere. I cannot write the code in the notepad or anything here. So we have to download the Visual Studio Code, right? So Visual Studio Code link is also available. I'll share these notes also with you guys. Don't worry. After the session, every day you will get the notes as well. So you see that, okay, this is the download page of the Visual Studio Code. Sorry, my mistake. This one. I'll share the same URL also in the chat. You can take it from there. No, you don't need to go to the location or anything right now. So same thing, Visual Studio Code is available for the different operating system. If you are using Windows, simple download it. If you are using Mac machine, you can download it. Okay, ignore that warning for Zia, it doesn't matter. And then if you're using the Linux, you can download it also here. Okay, wait, we will talk about V8 engine once again. When we see the architecture, it will be crystal clear. Okay, so who is not having Visual Studio Code? Yeah, you can download from the Microsoft Store also. Okay, don't need to raise your hand. Just say yes or no in the chat. If you're already having it, no need to install it again. See, just like this in my system, I'm already having it. So I don't want to install it again. If you don't have it, just simple click on this Windows and then just it will give you the zip file and then just open it from there, and then Visual Studio Code will look like this. Right now in my Visual Studio Code, the code is available. In your thing, it is a welcome screen and then blank page. Simple. Very, very straightforward. Okay. Now you, Abhilasha, if you're not able to see that, you have to restart your machine once. If you're not able to see the version. So that you can do it after the session. Fine. So very simple, like JavaScript configuration is super simple, not like, okay, environment variables, Java underscore home and all those things. We don't need to do it over here. No, whenever you come to this particular page, always it will give you the latest version. You see that, okay, version 1.0 is 8 available. You can download it. Why to download the older version of Visual Studio? If you're already having it, that's it. You can upgrade it later. Now, these are the two things that we have downloaded today, and it's available in our system up and running. Now, very important thing that we have to understand here is that how exactly V8 engine is working, and then how exactly my Visual Studio Code is also executing the program. Very important for interview point of view, right? So see this, and I'll show you a couple of things practically also here. So what is happening here, guys, that the moment I write my JavaScript code, no CLI, only zip, you can download Prabjot for Mac machine. Okay, no, don't need to download right now, Usha. You can download it later. So focus on the session first. Okay, the download and all those things, you guys can do it later. Still have any issue? You can just simple let me know. Got it? No, not CLI. Just simple. These are the X ARM64 is available, right? Simple download it here. Click on this click on this button. It will download it the right version. Okay. After the session, if someone wants to share one screen on Windows, I'll show you quickly on your machine as well. Okay. Now come back here. So again, back to the same question that, but how exactly this V8 engine that we are talking about, we have downloaded the Node.js. So now I'll say, okay, yeah, Node.js is available in my system. Let's see, for example, some version 22 is available in my system. Okay. And then after that, along with the Node, what are you getting? Along with the Node, you are getting this V8 engine also. Okay. This is also, we can say the JavaScript V8 engine, you are getting it here. It means now in my system, V8 engine is there. It's internally available now. It's running in my system. Okay. So what happens the moment I write my JavaScript code here? Okay, any JavaScript code, any one single line of code also, if I'm writing, let's say I'm writing some app.js file. Okay, this is a JavaScript file. So what happens the moment we write the code and then after that we execute the code, and then after that, how exactly we are getting the output, right? So this is what we have to understand here. So this is, let's see, my JavaScript code. Once we write the JavaScript code, then the next stage is that there is a parser. This parser is provided by the Node.js, provided by the V8 engine. This parser will check what? So I'll write it over here. The parser, okay, will check couple of things. The first thing it will check that, okay, any, syntax errors are there or not. It will check that. Another thing it will check, okay, maybe some comments are there in your code, right? Sometimes we write the comments also. So it will remove the comments. It will check, okay, all the syntax errors are there or not, or maybe some spaces are available or not. So it will try to parse your code. It will say, okay, fine, let's see 100 lines of code that you have written. It will remove the comments from there because comments will never be executed. Any unnecessary spaces are available, it will remove that. If any syntax errors are available, it will tell you that, okay, hey, please fix this problem, fix this particular thing. Let's see some spelling wrong or something is wrong, some keyword is wrong you have written. So it will tell you those kind of problems, those kind of issues, and then parser will just parse your code. So for example, let's see here you have written, for example, 10 lines of code here. I'm just randomly writing, let's see, 10 lines of code with so many spaces, unnecessary comments that you have written by Naveen here. This code is doing something like this, plain English that, okay, let's see you have written. So parser will just ignore these comments, spaces and everything. And then whatever the exact code that you have written, it will just take it over here. Okay, so let's see, out of 10 lines of code, it is taking around 7 lines of code here, for example. And then after that, this particular parser will give this particular 7 lines of code will be given to the AST. So AST is also a small component. What is the full form of AST? The full form of AST is, see this. This is called the abstract syntax tree. Okay, something new term for you. But what does it mean? I'll show you practically also that how exactly AST will look like, right? So whatever the number of lines of code, let's see, that you have written, it will be divided into a tree structure. What does it mean, the tree structure? Tree structure means that, okay, yeah, in your code, how many variables that you have written, how many functions, let's say, you have written, how many expressions that you have written, do you have any classes, do you have any, any objects, any loops that you are using? If you're using the loops also, inside the loops, how many variables, let's say, you have defined over here. So it will try to segregate your code. It will try to divide your code into multiple components over here. Components like every code, every JavaScript code or any program that you are writing, having number of variables, number of functions, number of classes, objects, loops, for loop, while loop, this and that, right? And number of functions that you have written. So it will try to create a tree structure. Okay. Why it is creating a tree structure? So that it will be very easy to execute the program. And then this tree structure will be given to the interpreter. And what do you mean by interpreter? See, the full form of AST, what I told you, the full form of AST is abstract syntax tree. AST, remember that term. And what do you mean by interpreter? Interpreter in any language is helping me to run the code, to run the program, generate the output, right? So generally what we say, interpreter means, okay, yeah, line by line execution, line by line, it will check the code and then run it. But in the JavaScript, things are slightly different. Okay, it is not exactly line by line, Vishal and Lakia. So what exactly they do? So they will check this particular AST, the node, whatever the AST tree structure kind of thing that we are given to this interpreter. Now the interpreter speed will be improved. Now interpreter knows, okay, where exactly how many number of variables are available, how many functions are available. So it will be very easy for the interpreter to generate the output. But how exactly interpreter will generate the output now? This particular interpreter will say, okay, fine. Now we are going to compile your code. See, this is very, very interesting. Understand that. Interpreter says, okay, we are going to compile your code. Fine. So we will see there are two branches. You can see, okay, one branch is coming here and another branch is coming over here. I'll tell you what do you mean by compiler and what do you mean by bytecode here, right? So interpreter says, okay, whatever the number of code that we have got it from this AST, now we are going to execute this particular code. And this will generate one intermediate code. This is called what? This is called the byte code over here. See, this is the byte code. And this particular byte code later on will be given to where? Later on, it will be converted to the machine code. What do you mean by machine code? Can anyone tell me? Machine code means a binary code, because machine understands what? Machine understand only 010101. See, my laptop does not understand anything. My laptop says, okay, only 0101. I don't know what is A equal to 10 or B equal to 10 or name equal to Naveen. I don't understand that. Machine says, whatever you have written, okay, everything will be end of the day, everything will be converted to the machine code. And this particular entire byte code will be converted to the machine code. And then from the machine code, what will happen? Machine will give this particular binary code to whom? In our college days, we used to remember one thing, we used to do this thing. What is the hardware language? The assembly language. Okay. I'm not saying, okay, guys, if you're not aware of it, perfectly fine. No worries. This is just to get an idea. Assembly language. Remember microprocessors, 8085 and CPU processors that we used to use. So assembly language will understand this particular machine code and everything, and then it will generate what? Then the machine language or assembly language will generate the output for me that, okay, hey, you wanted to print Naveen, or you wanted to print 10 on the console. That's why the 10 is getting printed on the console. That's why we are getting the output in the Visual Studio Code, right? So these things are done by the bytecode. First of all, that whatever the AST is coming, AST will be given to the interpreter. Interpreter will convert the bytecode. And what is the bytecode? How exactly it will look like? I'll show you that as well. Can we understand? Can we read the bytecode? In Java language, just to knowledge point of view, what is the bytecode? Remember dot class. After the compilation, dot class file be created. So same thing here in JavaScript also, bytecode will be created. And this bytecode is not human readable. As a human, we cannot read the bytecode. Okay, this is like something very weird code. I'll show you that code also. This is, you can say, intermediate code. Intermediate code, or you can say a byte code will be generated here. Human cannot read this particular code. And this intermediate code or byte code will be given, okay, will be converted to the machine code, and then machine code to the assembly, and assembly to the output. We are getting 10, 20, 30, whatever you're printing it on the console, it's doing that. Okay, this is the one-way process. But let's see what happens. You have written a very complex code. Might be possible, right? Complex code means, let's see, you have written a very lengthy code, 100, 2000 lines of code that you have written. And let's see, you have written something like this. I'm just writing a very simple code for you guys. So let's see one for loop that I'm writing. And in this particular for loop, let's see, I'm calling one function, let's see, add function. And this for loop I'm running from 1 to 1 million times. Okay. So try to understand, okay, how many times this add function will be called. Wait, Shantala. How many times this add function will be called? It will I equal to 1, and then up to 1 million times this add function will be called. Right? So this is not a normal code. So these kind of lines of code are called what? Again, it will do what? Again, it will do the same processing. That, okay, fine, it will be given to the parser. Parser will not do anything. Parser will say, okay, any comments are there, let me remove it. Any syntax errors are there, let me check that. If any kind of, spaces or unnecessary spaces are available, let me check that. It will just, decorate your code. You can say like this. And then again, it will be given to the AST. The T structure will be created. From the T structure, it will be given to the interpreter. Now the interpreter will supply this code to the compiler. Compiler will check this code is a hot code or the cold code. So you tell me what kind of code it is. This is a hot code or this is a cold code. Hot code is called HOT. I'm talking about hot code or warm code is called, that code is getting executed again and again. Right? So this is called the hot code. So compiler says, okay, fine. In your code that you have given to me, there are n number of lines are written which are getting executed repeatedly. For example, this add function is getting called, executing n number of times, million times. So we need something very important thing here. So we need to handle it in a different way in that case, right? Then you can say, okay, then why it is not creating the bytecode immediately? right? Because this is the interpreter will give this particular code to the compiler. Compiler will check what is the intensity of this particular code. This code is really normal code, the cold code, or the hot code. Compiler says, okay, no, this is getting executed n number of times. So let me optimize your code. And then the optimization will happen over here. I'll show you how exactly it will optimize, right? So it will optimize the code. And then after that, it will generate what? Then after that, after the optimization, it will generate the bytecode. And then after that, bytecode to the machine code once again. Machine code is like your binary code 0101. And then we are getting the output over here. If compiler says, okay, no, your code is absolutely fine, there is no hot code here, immediately it will generate the bytecode here, and then it is generating the output here for us. So who is recognizing that your code is having the hot code or not? Which component in this entire diagram you see? This particular compiler. And this compiler is also called, can anyone tell me, have you ever heard about JIT? What is the full form of JIT? In Java also we have that. In JavaScript also we have this just-in-time compiler. And this compiler is behaving like, in JavaScript language, we call it, this is called a turbo engine or turbo fan. You can see that. See what happens generally when we start the car. And let's see, if I really want to beat a Mercedes or really want to beat a Ferrari, and you are driving a normal car, so you will speed up, right? So this is what the turbo engine will start. The turbo fan will start to cool down the engine. So this is done by this particular compiler. Exactly same terminology used in JavaScript also, that this step is called the turbo engine. Turbo engine says, okay, fine. Whatever the hot code is available in your code, which is getting executed again and again, 1 million times, 1,000 times, 100,000 times, let me optimize the code. Let me cool down the code. Let me do the proper memory management or optimization, and then we will execute it. But turbo engine will come into the picture for the normal code. Normal code means, let's say I simply create a normal variable here. Let's see, hey, x is equal to 10, and then y is equal to 20. And then I'll say z is equal to, let's see, simple x plus y, which is equal to what? X plus y is equal to what? X plus y will give you 30. So this code will be given what? Again, parser will check any syntax error or anything like this. It will be converted into the AST to the interpreter, interpreted to the compiler. Compiler check, okay, is it a cold code or warm code? What do you think about this? This is a normal code. This is a cold code. Cold code. So in that case, no, I don't need to start the turbo engine. A simple say, okay, fine. Just simple give it to the bytecode. From the bytecode given to the machine code like 0101, and then finally assembly, and then giving me the output over here. Exactly. So JIT is behaving what? JIT is behaving like a catalyst. And this process is also called, anyone, this is also called the profiling. You can say the optimization of the code. Okay, by using what? By using the JIT. And JIT is what? JIT is like a compiler. So don't get confused with the Java compiler and all those things. JIT itself, its name itself is a JIT compiler. This compiler will come into the picture only when it sees there is a hot code or not. If there is a no hot code, this JIT will not come into the picture. Who will decide? We cannot decide that. We cannot take a decision here. This is designed by this V8 engine. This is how the V8 engine works. Exactly in the car also. When you're driving a normal car, I mean, normal speed in the city, there is no turbo engine. But if you're running on the highway, right? We're running the car on the highway, then you start the V8 engine or a sports mode, and then your car is going super fast. The turbo engine will start and all those things. So it is decided by the engine, not by us, not by the driver. So we cannot write the code according to the compiler, according to the interpreter. We will write the code according to our functionality, whatever I want to achieve. If I really want to write a for loop, which will execute 100 times or 1,000 times, I will write it. Interpreter and the compiler will decide it is a hot code or it is a cold code. Right? So if you more deep dive into it, see this. See, this is a better diagram here. Again, you see that, okay, source code, because this is a very famous interview question. People will ask, tell me the architecture of V8 engine. How exactly a V8 engine is executing the JavaScript code in your system, in your laptop. With the help of V8 engine is coming along with what? I just told you. V8 engine is coming along with the Node.js that we have downloaded. Okay, along with the Node.js, not with only JS, Node.js. So what is happening here? Again, see, this is my source code. Source code means the code that I'm writing. It will parse it. Parsing will check only basic stuff. This is just to decorate your program or remove unnecessary things. Okay, perfect, looks perfect. All the keywords are written properly, true, false, and everything. Let's see, instead of true, I'm writing only TRE. So obviously it's a syntax error, right? So many comments that I have written. So in that case, parser will remove those comments. It will not participate in the execution. So let's see, out of 100 lines of code, 10 lines of comments that you have written. So what are the actual lines of code? Right? So out of 100, let's see 10 lines of comments that you have written, but actual lines of code only 90, right? So this is what the parser will do. It will give you the error also in the Visual Studio Code because the parser is running in the background. I'll show you that as well. And then parser will say, okay, fine, for this 90 lines of code that you have written, I'll show you the AST diagram also, how exactly AST will look like. This is your abstract syntax tree. It will just check the entire, these 90 lines of code, and then it will check how many variables are there, how many functions are there, how many loops that you have written, how many if else conditions that you have written, how many functions that you have written, classes, objects, everything. It will just segregate into multiple parts, and then after that it will be given to the interpreter. Okay, so this is what inside the JIT is happening. This is the whole interpreter process will start. It will monitor. The monitor step will come. Is it a hot or warm? Okay, warm means you can say cold, right? So hot code, if it is a hot code or if it is a warm code, decision will be taken accordingly. We cannot take that decision. If it is a warm code, it's a normal code. Okay, yeah, simple interpreter, please generate the byte code to the machine code, and then please give me the output here. Done. No turbo engine, nothing. No optimization. But if it is a hot code, if it is yes, then the JIT compiler will come into the picture. It will decide, okay, yeah, there is a hot code. Let me optimize this particular code. So they will use some internal optimization techniques written by, V8. That is, we are not bothered about it, how exactly they are going to optimize. And then after that, they will generate what? After that, they will generate the same, a machine code. And then after that, they will give me the output over here. Ultimately, we are getting the output. But the hot code process is different and the cold is different here, right? So if you see that, let's see, for example, if parser catching the error, we should not execute that code. Simple, Swamika. If some syntax errors are there, we have to fix that problem first, right? Otherwise, it will give you the error at the runtime. No, just ignore the store. Store means simple, normal, okay, internal inside the memory, it will store the code somewhere. See this more better example if you see that here. This is again Node.js. Node.js is having this particular V8 engine. No, don't get confused with the, okay, interpreter is coming before compiler. It's the whole thing is part of interpreter plus compiler combination. Okay, don't go to the actual meaning of, why it is coming first or why it's not coming first. Okay, this is slightly different, but here you will see a clear picture over here. Optimization means if the hot code is available, the code will be optimized. It will just behave like a catalyst in between. Because you think about 1 million times I'm calling a function. Don't you think it is taking, let's say, around 20 minutes or 15 minutes to execute the code? So it will optimize the code. It will try to put more resources. It will try to put more library, better memory management to execute that particular code. This is called optimization here. Okay, I'll show you the example as well. So now see, if someone is asking, can you please again tell me what are the different stages of the V8 engine? Chrome V8 engine is used by Node.js also. So that's why you see that, okay, Node.js is a complete kit. Inside that kit, this V8 engine is running. And this is my JavaScript code that we have written. Again, parsing, AST, bytecode, machine code, and then code is running on your CPU. CPU will give you the output. CPU means your assembly language. Okay, and when exactly the turbo fan will be, okay, will be considered or will be activated? Only and only in case of hot code. Only if it is needed to optimize the code, then only the turbo engine will come into the picture. I'll show you practically also, okay? I have one very good example. I'll show you that. So on the basis of that, the decision will be taken. If you have written only, let's say, only 5 variables, just simple run it and then execute it. There is no hot code. then the normal execution will happen, right? So see this, that's why it's like V and then 8. Again, you see that, okay, this is your JavaScript code and then simple parse it. Yeah, you can say this is a life cycle of the JavaScript program. Okay, or you can say the V8 engine life cycle also. Parse it, abstract tree syntax. This is the bytecode got generated. What I told you, can we read the bytecode? No, we cannot read it. This is not human readable. I can read only what I'm writing here. A equal to 10, B equal to 20. I'm calling a function, writing dot click dot fill method or any playwright code. I can read those things. After that, the bytecode is generated. I cannot read it. Same thing in other languages also. I cannot read it here. Right? So in that case, again, see this, and then it will check the feedback. It's a hot or cold. If it is hot, turbo engine will start, the turbo fan will start to cool down because it's like 1 million times. Let's see if you're executing some code. So obviously we need a turbo fan here. It's not like actual turbo fan, guys. This is naming that they are using it internally. This is what the V8 engine will work. So they are just actually try to relate with the actual V8 engine in the car. And once it says, okay, fine, we have optimized the code. Now it's time to execute it. And then it will give you to the CPU processor, to the assembly language, because assembly is written inside the CPU. Whatever the CPU that you're using, Intel machine or ARM machine or whatever it is. And then it will just simple generate the machine code and machine code to the output here. Simple, right? So this is clear. So again, if you go to browser and then if I try to inspect, and let's see if I go to the console, and then if I write, guys, x is equal to 10 over here, which V8 engine is used, Node.js or browser V8 engine? This is a browser engine. Browser is also having its own V8 engine. This browser is not using Node.js, right? Try to understand that browser is having its own V8 engine. See, when we don't download the Node.js, I can still use my browser, right? If I click on this particular image, see, I'm clicking on it. One internally JavaScript is getting executed on the browser with the help of what? With the help of V8 engine. The moment I say, okay, hey, I really want to document dot get element by ID, and then whatever that I really want to use, if I say, okay, use this particular history object or window object or a scrolling object, all these things are coming because of the V8 engine. V8 engine is executing this JavaScript code in the browser. But I'm talking about the code that I'm writing in my system without the browser. Then which V8 engine will be used? That is coming from the Node.js. This is what you have to understand the difference. That's why we have downloaded the Node.js in my system, in our system. Right? Now let's see, do some practical thing so that, yeah, in theory it looks fine, but show me something. Okay. So let's see, we are creating a simple project today just to show you. Okay. We are not writing some high fundo things today because you don't understand the JavaScript. So I'll do one thing. I have to create a normal folder so that I can write my code there. So first of all, let's say I'll go to my C drive or D drive, doesn't matter. So let's say I'll go to my documents. So what you all do, create a new folder here. So see, I'm creating a new folder. And let's see, I'm writing, this is your batch name. Your batch name is what? Let's see, January 2026, Playwright JS batch. Something like this, JavaScript practice. Whatever the nice name you want to give, you can give it here. And you see that, okay, here, we don't have anything. It's a normal blank folder. But if you do the same thing in Eclipse, you have to create a Maven project and then create a Java project, add the JRE library. No, we don't need to do all those things here. It's very, very simple, very straightforward. Create a normal folder anywhere in your C drive or documents or downloads or anywhere. Then open your Visual Studio Code. So let me just open this Visual Studio Code. I'll do one thing. Let me open a fresh window here. And let me just see this. This is a window. First time when we open the Visual Studio Code with the welcome, close this welcome. Right? And then after that, I'll go to the file. And then after that, I simply open that folder. The folder that I have created, I'll open that. I go to my documents. This is a folder that I have created and then open this. Now this folder is available here. Okay. You see that, okay, let me just simply maximize it. You see that, okay, this is the folder, welcome screen is there, just close it. You can just check it here. You see the folder name is visible here. You don't need to create any src main Java, test Java, and all those things. Nothing to worry about it here. Now I really want to write my first code. Where should I write? In this folder. So see this, I'm going to create a normal file. So I'm going to create a file here, any file name. Let's say I'm giving app.js file. What I told you yesterday also, today also, whenever we are creating any JavaScript file, what is the extension? .js. .js means JavaScript. Okay. Later on, when we type the TypeScript, we will write TS. TS means TypeScript. JS means JavaScript. .java means Java file. So we are creating normal any file name, whatever you want to write, app.js file. Okay. So this is a file and here I can write the code, right? So let's say I'm writing anything. For time being, I know today you don't understand, Naveen, what is let variable or any variable. Ignore that let variable. I simply say x is equal to 10, for example. I'm writing, okay, let y is equal to let and all those things we will see in the next chapter. So I'm just creating two variables, x 10 and y 20. And then I'll say, okay, let z is equal to x plus y. And then I really want to print it on the console, the value of z. So what is the value of z, guys? Simple mathematics, 10 plus 20 is equal to 30. So let's say I'm writing 30 over here. Simple, very straightforward. So now I really want to run this particular code. So how will you run it? So I simply say I'll open the terminal. So I can execute that, right? So I'll open the terminal. Can you see the first top menu item is there? Terminal is there. Open a new terminal here. And you see that, okay, the terminal window is available. And then let me just simple run it here. How will you run this code? Which command that we have to run? Simple write node, because with the help of node, I want to run my code, right? So I simply say, okay, node, which file you want to run? The file name is app.js file. And the moment I run this is giving me what? See, the output is 30 here. But internally, what happened? Now you try to relate the things. Internally, what happened? According to this particular V8 engine, internally, this particular .js file, first of all, will be parsed. Okay. And then after that, it will be given to whom? You tell me. It will be given to the AST. What is the full form of AST? Abstract syntax tree. How exactly it looks like? Let's see that. Okay. So there are multiple online tools are available. You can visualize the AST, guys. Okay. You can just open this particular tool. See this? I'm just opening it here. AST.NET, something like this. AST Explorer.NET. And the code that I have written, see this, I'll just copy this code from here. I really want to know how exactly the AST will look like for my code. I copy and then paste it here. This is how the AST will look like. Can you see the tree structure here? It says, okay, this is your program starting from 058, some, internal thing. And this is a body. Can you see variable declaration? You open that variable declaration and then it says, okay, yeah, variable declaration return with the let over here, the value is 10. And this is the identifier. What is the actual value? The actual value is 10 over here. See, this is how it will divide your code. Then after that, I'll say, okay, fine. Variable declaration is fine. See this, let me just show you once again. See this, one more variable declaration for Y, then one more is there. And then what is that? We have this expression statement. We are printing something on the console. So see this, it says, okay, yeah, call expression. So it will just, this is the AST tree, guys. This is how the tree will look like. For example, let's see, I have a lengthy code here. See this one. Okay, you see that, okay, let me just simple write it here. See, I'm writing some functions also. I'm writing more variables. I'm writing more things over here. So AST will automatically increase. For the function, it's showing me what? See, function declaration. Can you see? When I mouse over here, it's highlighting line number 18 to 23, right? So tomorrow, let's see if I'm creating anything. Let's say I'm creating one for loop also here. And then in that case, it will start giving me the AST for the for loop also. For example, let's see, let I is equal to 0. And then I'm writing I is less than equal to 10. And then I plus plus, and then do something. See? So for the for loop also, see, for a statement, the AST is actually created. No, 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 no. This is Mukul. This is different. The DSA graph is different. This is not the binary tree graph or anything here. Okay. Yeah, you can relate those things with this. Yeah, you can say that. because this is helping us, not helping us. This is actually interpreter is now super happy. See, you try to understand. See, if I give this entire code to the interpreter will take time, right? Okay, line by line it will execute. Okay, line number 3, line number 4, line number 5. What if tomorrow you have 1,000 lines of code? So interpreter will take more time to segregate the code. This AST is actually helping me. Okay, this AST, no, this is just internal identifier. We cannot tell what is start or end over here. We are not bothered about this thing. We are bothered about, okay, proper expression AST diagrams coming here or not. I mean, AST nodes are coming here or not. You see that, okay, for a statement, see, for a statement got generated. I'll open this particular for a statement is saying that, okay, here, this is a kind of block that you have written. Block means curly braces that you have written. Inside that, this is what you have written over here. The body is blank because we have not written inside the for loop. Right? No, no, right now, please don't bother about X or X over here. We don't know what is global and X or all those things, right? Just try to, okay, if you're getting confused, remove this line. Simple two variables, X and Y, we have created here. So the moment I update my code, add my code, delete my code, automatically AST is getting updated here. Right? That you understand? Right now, please don't compare what is let, what is without let, because today you will not understand those things. We will cover how to declare the variable and all those things from the next chapter onwards. Today, just try to understand here, for everything, every expression, every line of code, it will generate a separate AST code here. This is how it will look like. So this is what I have actually told you here. The AST syntax tree will be generated. Now it will be given to where? To the entire thing, this interpreter. Right? So now how exactly interpreter will do that? So the first of all, you tell me this is a hot code or normal code. Can we say it's a normal code? It's cold code, not the hot code. But again, we cannot decide. According to us, it's a normal code. Okay, very, very normal code. We can say that. But I really want to check how exactly V8 engine is considering it. Right? So see this one by one, step by step. So now I really want to do some experiment here. First of all, I really want to see what is the source code of this file. Okay, sorry, this is my source code. And what is the next thing is that what is the byte code of this file? Byte code, can we read it? Can be human readable? The byte code? No. So I say, see, again, I'm running with the node, see the command, and then I'm using this particular command, hyphen print the byte code also of this. What is the file name? app.js. I really want to know that how exactly byte code will look like of my source code. See the byte code. Can you read this code? No, with Visual Studio Code, you cannot do it. You have to go to some online website that I shown you. Then only you can see the AST code. Within Visual Studio Code, we cannot see that. Okay, but within Visual Studio Code, you can see the byte code. So guys, this is the byte code. See, only 4 lines of code, such a huge byte code is generating. Are we able to understand this code? This is not at all human readable, right? What exactly it's doing it, I have no idea. So this is what, what is this? If I say that, can I say this is my source code? And this is what? This is my byte code. And this byte code will be given to whom? According to this, the byte code will be given to the, now later on it will be converted to the machine code. In between, it will check turbofan is really needed or not. So you tell me turbofan is needed or not. Turbofan means if the super hot code is there, turbofan will come and then cool down the engine, right? So same thing here. Just try to understand with that terminology. So here I'll say, okay, let's see turbofan is needed or not. So how will you check that that node is using or V8 engine is using a turbofan or not? So just try to run this command. I'll give you these commands in the box. Don't worry. See, let me just clear the console from here. And now you see that, okay, here I'll write, what is the file name? app.js. So the option that we use, trace opt. I really want to know turbo is needed or not. The moment I execute that, So you tell turbo is needed or not. See, it's giving me the output. What does it mean? It means the turbo is not needed. It's not giving me any other extra information here that I'm starting the turbo engine or I'm cooling down this particular code or optimizing the code. No information, nothing. Turbo is not needed for simple addition here, right? But now I'll do one thing. I'm writing a for loop. See this one example. Let's see, for example, I'm writing it here. Right now, you don't understand for loop functions and all those things. Don't worry. This is just to give you a basic idea. We will cover each and everything in upcoming chapters. I'm just giving you an idea. One function that I have created. This is the add function. And can you tell me how many times I'm calling this function? See this? I'm starting a loop I equal to 0. And I'm running, see, something like, I think 100,000 times, something like this. 1 million times, for example. And then I'm saying, okay, please call this particular function add 2 and 3, and it will just keep adding 2 and 3, 2 and 3. So 100,000 times I'm calling this particular function. Now the turbo engine will be activated or not. Interesting to see. Let's see this. So again, I'm saying that. I'm saying node, please run this code, but give me what actually you did internally. So this trace opt will help me to understand that. Now see, I'm running it. Can you see? See, is it still giving me the output? Output is coming as 30 only, whatever you are printing it. But it's giving me, can you see? For optimization to turbofan. It means the turbofan is started here. And see, the reason is the hot code. Okay, see, it's clearly written here. It's hot, but the code is stable, but this is a hot code. We are starting the turbo engine, and the reason is hot here. And then we are transferring this code to the turbo engine for the optimization purpose to turbofan. And the turbofan will start, and then after that, it's giving me the output here. See, interesting example. So this is a hot code, a warm code. I mean, hot code or the cold code. This is a hot code. Then again, I'll check, okay, what if, see, someone is asking, what if I'm writing only 100 times? Can we decide this is a hot or cold? Let's see this. I'm saying, okay, no, just run only for 100 times. Let's see what happens. See, hot. This is hot code or not? Now it is not, because only 100. 100 is nothing in programming languages. But if I say, okay, let's see 1,000 times, again save it and again run it. Let's see. Again normal, no hot, no turbofan started. Again, let's see 1,000 times or 10,000 times. Again, let's see this. Yes, auto-save. In the Visual Studio Code, it will be auto-saved. But the moment I write 10,000, turbo engine started, I mean, turbofan started or not? Yes. So you tell me, guys, who is taking a decision here? The developer, the programmer is taking a decision, or the V8 engine is taking the decision here? Engine is taking a decision. It's not decided by us. I cannot say, okay, no turbo engine start or not. No, there is no code like this. There is no method like this. Engine will automatically check. This is the feature of the V8 engine. This is a feature of the V8. It will decide, okay, it's there or not. That's why the complete workflow, the complete life cycle that I explained to you, this is called the hot code is there. Okay, let me optimize your code. Let me start the turbofan, and then I will give you the output. Output is still coming, but with through optimization process. This is clear. Okay, so this is clear. If someone is asking you at a time of interview, can you please tell me about the AST? And after AST, what is the use of AST and how exactly the interpreter and the compiler is working? This is how it's working here. Right? So that's why, like, after V8 engine, this is a powerful concept of the V8 engine. That's why it is so famous by other browsers also. Other browsers also impressed by where exactly that table? Yeah. See this. That's why the other browsers are so impressed with the V8 performance. They all started using the V8 engine internally. Same thing is happening in the browser also, because ultimately it's a V8 engine only. Yes, people will ask these kind of questions, especially with the V8 engine process, how exactly JavaScript works. That will be the first question. I'm not saying everyone will ask, but what if they are asking the language that you are using it, if you're not sure about it, how exactly it works internally, then then you are not confident in while writing the code. Okay, yes, other engines also works in a very similar kind of way. Then you have to read about, okay, how exactly Nitro works, how exactly SpiderMonkey works, but their performance is not like V8 engine. V8 is like a standard in the market right now, okay, to used by other browsers also. So that's why like Opera, Brave, most of the Samsung OnePlus browser that you are using it, they all are using V8 engine. Okay, see, Vikram is saying I faced this question in the PBC company interview. See, people are asking these kind of things. Correct? This is clear. Interesting topic. Okay, one more interview question. So you have to tell me that Java versus JavaScript versus C language. Which one is faster and why? Hmm? Okay, we will consider C language in some time, but between Java and JavaScript, which one is faster? Or we can say, let's see, just like Java, we have C Sharp also. Just like C Sharp, what we have, let's see, we have Go language as well. Which one is faster? JavaScript or the Java? No, Java is faster, guys, as compared to JavaScript. This is what you have to understand here. Okay, and then we will consider C language also. See what is happening here. This is very, very important topic. So what happens, I'm not talking about, okay, how exactly Java works, but I'll give you a basic idea. Java says that Java is what? Java is what? Is a compiler plus interpreter language. What does it mean? Hmm? Most of the people who are coming from Java training, they are already aware of this. So Java says that, okay, the moment you write the code, 80% of the things we can say is already checked at the compile time. CT means at the compile time. Okay, it means the code, we have already checked syntax error or any kind of error or integer variables and all those things, everything we have checked for you. And then at the runtime, how much percentage is left? 20%. So don't you think that, okay, only 20% things will be checked at the RT. RT means runtime. In Java, I'm talking about. This is for the Java. So you are bothered about at RT or you are bothered about CT? Think about as a customer point of view or client point of view. Client is not bothered about what is CT and all those things, right? Client says, okay, when I run your code, when I run your application written in Java, it should take less time. Okay, so Java is having a very powerful compiler. The moment I write the code in Java, what we do, we compile the code and then 80-90% things are already checked at the compile time while writing the code. What does it mean? It means in Java, if I write, guys, integer I is equal to 10, Java compiler has already decided that, boss, I is a number. It will not be decided at the runtime. In Java, if I write it like this, string name is equal to Vivek. Java has already decided that name is what? A string type. But in JavaScript, what happens? When we write something here, let's see, let x is equal to 10. If I'm writing let y is equal to true. Okay, let's see if I'm writing let z is equal to Naveen. I'm just writing the code. No one is deciding x is the number, y is boolean, or z is the string. Everything will be decided where? Everything will be decided at the RT time, runtime. It means 100% things will be decided at the runtime. And in 100%, all these processes, V8 engine and all those things, optimization, everything will be decided at the runtime. So don't you think it will take more time? What do you think? You think about a application, one application that you have designed with the JavaScript. When you run the program, and then it will decide, okay, yeah, okay, let me check x equal to 10. Okay, now it is a number. Okay, this is Boolean. Everything will be decided at the runtime. Okay, Naveen is a string. Okay, string. But in Java, it's already decided at the compile time. In C Sharp, in Go language, it's already decided at the compile time. So that's why the JavaScript is also called. JavaScript is a runtime language or compile time language. It is a RT language, or you can say a dynamic language. Dynamic means everything will be decided at the runtime. Very similar way, Python also works in the same way. That's why Python is slower than Java. But Python is famous for the machine learning, because scientific calculation, machine learning, AI intelligence, because Python provides number of libraries. But Java is used for the enterprise level application where I need a very strong backend. Quick search algorithm, quick, fetching the data from the database and then show it on the UI. Supply from one API to another API. Because I want to do a quick execution. For that purpose, we write the backend with Java, Spring Boot, Go language, and all those things. That's why the JavaScript is a dynamic language. Dynamic means especially designed for the web applications, especially designed for the tools available in the market like Playwright, Cypress, and all. And I'll tell you, I got your question that, okay, someone is asking then why Playwright is faster. Okay, I'm come to that question as well. Got it? So this is what you have to understand, guys. Language is slower than, JS is slower than the Java, because JS is like everything will be decided at the decision will be taken at the runtime. Okay, and we will see that when we write the code in upcoming chapters. Right? See, for example, if I go to Eclipse, okay, and then see, I'm writing one code here. Integer x is equal to 10. This is Java code. Okay, can I write x is equal to Naveen? See, it's giving me the error. Who is giving me this error? Compiler. See, compiler is already giving me, boss, this is wrong. Please fix it. So you will not get the surprises at the runtime. But now you do the same thing in JavaScript. See, I'm coming over here and then I'm writing one variable here. See, I'm creating, okay, let I is equal to 10. And then I'm writing I is equal to Naveen. See, no error. Okay, wait, I'm coming to the TypeScript also. See, no error. At the, okay, runtime, we will get to know, okay, what is the actual I? I is number or string? I is actually here, no one is deciding it. It will be decided at the runtime. That's why JavaScript is actually a dynamic language. It will be decided at the runtime. And the Java is a compile time language. Java says, okay, no, you cannot do that. Right? So let me just remove it. We are not talking about Java here. And then again, you come back here. Okay, so this is clear. Why JavaScript is slower than Java and C# and Go language. All the compile time languages are available in the market faster than the runtime languages. JavaScript is one of them. Python is also slower. Python is also dynamic. Now I'm coming to the point. Then you say, okay, no, Naveen, then why Playwright is faster than Selenium? Because of the Playwright architecture, not because of the language. Tomorrow you can say Playwright Java also I can use it, right? So Playwright is faster because of the Playwright architecture, not because of the language, right? Here we are talking about, here we are doing the comparison between the language to language. This is clear? Because Playwright architecture exactly is using some WebSocket and all those things. That's a different architecture to speed the performance of running the, executing the code. That's a different concept. Now, last point. Why C language is faster or C language is slower than these guys? See this C language. C language, just why, have you ever heard about C language is also called the hardware language? Right? So let's see if anything I'm writing one app.c. Remember C language in our school time, college time, not school time, college time. We used to write the code, main method, and then and all those things. This is the source code. Let's see, I'm writing here. Okay. And this source code will be converted immediately to the machine code. Machine code is what? 0101. There is no intermediate code. Right? So that's why C is very faster. There is no simple source code to machine code, done. And then after the machine code, machine understand 0101 and it will give you the output here. But in Java, what is happening? Let's see, you're writing test.java. First, it will be compiled. It will convert what? Test.class file. Then after that, it will be converted to what? It will be converted to the machine code like 0101 and then is giving me the output here. Right? So that's why C language is used for robotics, hardware configuration, IoTs and all. We use the C language. But the same thing, let's say I'm writing with the JavaScript. What will happen with the JavaScript? App.js. So many steps, parser. After that, AST. After that, the code will be compiled. Compile means the bytecode will be generated here. Bytecode to where? Bytecode to the, once again, machine code. Machine code 0101 and then giving me the output. So now you clearly see the difference here. Who is faster? Who is reaching to the machine as soon as possible? C language. C language says, okay, yeah, this is a source code, immediately convert to the machine code. But that's why these are called the low level languages. And the JavaScript and Java, these languages are called the high level languages because they have the bytecode intermediate. It will convert the bytecode, then bytecode to the machine code. Okay, but C language is having its own problem, no better object oriented and all those things. That's why C++ came into the picture. And then Java and all those things came into the picture here. This is clear. Okay, so this is just to give you an overview, guys. You should think about, okay, why, okay, not randomly. Whenever you're talking to someone at a time of interview, to the developer also, you understand the things, you understand, okay, yeah, these things works in this way. Okay, now one last thing, sorry, I just missed, although we will cover this part also, TypeScript. TypeScript is what? TypeScript is like JavaScript. Sorry, it is like Java. TypeScript also says, okay, fine. First, whatever the code that you're writing in the TypeScript, we will convert to the JavaScript. And then after that, the same process will start here. We will parse it, we will generate the machine code, and then we will give you the output here. What I told you, TypeScript is a wrapper on top of JavaScript. Okay, so whatever the code that you're writing in the TypeScript, then it will be converted to the JavaScript. JavaScript, then parse, and all those things will start here. So can I say the TypeScript is slower than the JavaScript? Yes, it is slower than. Why? Because of the extra step got added here. But TypeScript is having some powerful feature. TypeScript is not the runtime language. TypeScript is also a compile time language. The moment you write the code in the TypeScript, any error or any problem that you're writing, any syntax error or anything, immediately it will tell, okay, no, please fix it, then you run it. Same thing here, 80% things will be checked at the compile time. And then 20% things will be checked at the runtime, like Java. So that's why people like this particular language, because while writing the code, while developing the code, I'm getting most of the errors. I'm not getting surprises at the runtime. Because in JavaScript, that's why I told you yesterday also, guys, if you're writing starting Playwright, please start with the JavaScript, not with the TypeScript. You must have seen that, okay, you must have faced this problem also. The moment you write the code in the JavaScript, and then when we run it, then we will get to know, okay, yeah, this is a problem. Comma is missing, semicolon is missing. So irritating, right? But in TypeScript, you will not face these kind of problems. Yes, Mukul, when we talk about TypeScript, that time we will see that. Okay, how to add the libraries for that. This is clear. Okay, so again, quickly come back here. This is a V8 engine diagram. And again, this is the last diagram. You see that, okay, source code interpreter will, if the hot code is not there, warm code immediately to the byte code to the machine code, output will be there. But if it is a hot code, then the turbo fan will start. See, this is a sign of turbo. Profiling means optimization, optimize the code, then give it to the machine code, and then generate the output here. Okay, guys, remember this, practice this. People will ask this question at a time of interview. Please tell me the V8 engine lifecycle or how exactly JavaScript executes in your system and in your browser. Both are two V8 engines we are using it. One for browser, one for local system, one for our system. Clear? Yes, yes, I'll give you these notes. Everything will be available. Any question in this? One by one. Yeah, Ambika, you have anything? You can unmute yourself.
Yeah, Naveen. So for the browsers which are not
Mhm.
built on V8 engine, then the Node.js will not be used. For example, Firefox.
No, that okay, very, very good question. So see this, for example, let's see Firefox, we are using SpiderMonkey. So
Yeah.
Playwright is still using Node.js. Very good question. See this. So let me clear it. Okay. So let's see, this is my Playwright code. Fine. Playwright code says, okay, fine. I'm giving this port to the Node.js. Fine. And Node.js says, okay, fine. We are interacting with the Mozilla Firefox. Now it will send the request to the Mozilla Firefox. Mozilla Firefox will use this particular SpiderMonkey okay, engine to interact with the Firefox. Okay. So to interact with the Firefox, I need a SpiderMonkey. But to write the JavaScript code in my Visual Studio Code and anything or any Playwright code, I need Node.js V8 engine. So here locally, I'm using V8. But on the Firefox, we are using, the Firefox is actually using, and Firefox is clicking on the button or anything, is doing what? Is using the SpiderMonkey engine. This is clear?
Okay.
SpiderMonkey has an interpreter for it. Yes, SpiderMonkey is having its own internal mechanism on the Firefox. It's Firefox problem, right? Firefox also SpiderMonkey says, okay, fine, we will also, okay, maybe AST or whatever the internal structure of the SpiderMonkey. It's not famous, so that's why we don't need to worry about the architecture of the SpiderMonkey. Yeah, Subhashish,
Uh,
Swamika, Ankur.
Hi, Naveen. I have one doubt. Earlier, you told that in an browser, it will use the V8 architecture, and then when we write the code in locally, like in VS Code, then it will use Node.js.
Correct, yes.
When we are using like writing the code in VS Code, then Node.js, how it like help in like instead of V8.
Okay, see this. Once again, I'll quickly repeat this. Okay, can you see this diagram?
Yes,
This is my source code.
right.
Okay, so I'll say, okay, guys, this is my source code. Let's see, our source code is writing in the Visual Studio Code. VSC means Visual Studio Code. And here I'm writing my code here. This is my .js file, right? Now, if I really want to execute, forget about browser. If I really want to execute, what I need? Node or browser?
Node,
Node.js. Along with the Node.js, what are we getting? V8 engine, we are getting it, right?
right.
But now let's say I'm saying, okay, no, this is my Playwright code. That is the main confusion. Now this is, let's see, my Playwright code along with the JavaScript that I'm writing. Playwright is also sending this particular code to whom? To the Node.js server.
Right.
And Node.js server is also having the V8 engine, same process. But now the actual thing will happen over here. See, Ambika is also asking the same question, or you are almost asking the same question. Here, let's see, two browsers are available. This is my Chrome. I'm talking about now the browser. And this is, let's see, Firefox.
Okay.
Okay. And let's see, this is one more browser that I'm creating. Let's see for the Safari, which engine we are using for Safari. You can say WebKit, or another name, you can say Nitro engine.
Okay.
So they all are having their own engine. So let's see, this is my, over here, we are having the V8 engine, and here we are having this, SpiderMonkey engine that we're
Right.
using it. Okay. So now when we write the code locally in my system, in my Visual Studio Code, this is my .js file or .ts file, whatever I have written. It will use which engine? The Node engine or the browser
Node,
engine? Node engine.
Node engine.
Exactly, right? So it will go via this process, Node engine. It will be given to the Playwright server, and Playwright server will send this request to the browser. Now the
Browser.
browser says, okay, fine, boss, I got your request. I want to execute .click, .send keys or anything over here. Now the Chrome will read this instruction and then interact with these elements using which engine?
V8.
V8 engine installed where? On
On
the
browser.
inside
Okay.
the browser. Okay,
Got
this is
it.
the thing. Same thing I say, okay, no, send the request, please interact with the Firefox. So it will go to the Firefox. I want to click on the button. I want to enter the value. So which engine will be used? A SpiderMonkey or V8 engine? So here it will use this particular SpiderMonkey here. Same thing with the Firefox or Mozilla, or sorry, Apple Safari as well. So locally,
Okay.
whatever we are writing, we are using Node.js V8 engine. The moment we reach to the browser, we are using browser specific engine.
Okay, got it, Navin. Actually, when we are locally writing the code, it will use the Node.js. After that, it is the browser behavior, whether it is using
Exactly.
V8 or SpiderMonkey, it will internally use their architecture.
Exactly. Yes. Perfect.
Okay, okay.
Hmm?
Thank
Yeah,
you.
hi Naveen.
Yeah, Ankur.
Yeah, so two questions. The browser engine is only with JavaScript.
Yes. Always and always JavaScript.
Okay, so what is the reason? Why not with Java or TypeScript or some
Because
other
browser is
language?
designed with JavaScript only. Browser understands only JavaScript, no other
Okay.
language.
And one more thing, Naveen, regarding the box one. So
Mhm.
I have replied to you actually. There are some issues. I already pasted the screenshot and all, so you can check and you can revert it back once
Sure,
you
sure.
check.
I'll do that,
Thank you.
Ankur.
Thanks.
Yeah. Yeah,
Hi,
Sonika, you
Naveen.
have anything?
Yeah. So I have one question. So this browser engine is basically designed to execute the JavaScript code. That's it. Or it has some other responsibility or for the browser.
So many responsibilities. V8 engine is
Mhm.
helping me to identify the XPath also, CSS selector also. There are like so
Okay.
many other, features also available in the browser for this V8 engine. V8 engine, the moment we write XPath in the browser, have you seen XPath? Double
Yeah,
slash,
yeah.
this and that. Why
Yeah,
it's
yeah,
giving
yeah,
me
yeah.
one of one? Who is giving me one of one? The browser engine, the V8 engine is actually, helping me
Okay.
to identify that XPath.
Okay, got it. I have one more question. This regarding this hard code. So you have
Hmm.
shown one example with the for loop. So where we
Hmm.
have a repetition of the code, then we are checking whether it is required the turbofan or not. But in
Correct.
case of like a recursive function or I mean repetition of code only, it may be
It depends.
required.
It's
Yeah.
getting repeated more than, let's say, 100 times, 1,000 times.
Mm-hmm.
JavaScript will consider as a hot code. But there is no
Okay.
fixed identifier here, that, okay, only after 100 or only after 1,000. It is JavaScript
Okay.
problem. Internally, they will decide.
Okay, so basically it is for the repetition of the code wherever it sees the multiple repetition and then it is going for that,
Exactly.
right?
Yes,
Okay,
correct.
okay, got it. Yeah. Thank you.
Any info on the Nitro, you can check on Apple website. Not much information available. This is not important for interview. Just know the name. That is more than enough. V8 is very popular actually. Okay, one by one. Yeah, Vijay, quickly, you have anything? Okay, if no question, then yeah, Vijay, you have anything quickly? Okay, Pallavi, you have anything?
Hi Naveen, am I
Naveen,
audible?
can you hear me? Speaking on mute.
Yeah, go ahead, please. Quickly, guys. Please be ready,
Naveen,
guys, with your mic and everything, so that we'll
yeah,
not
can
waste time.
you, yeah, can you just show that diagram, Naveen?
Hmm.
No, not this one. The pictorial diagram that you wrote for that V8 engine question.
This one or in the paint?
No,
Sorry.
yeah, in the paint that you draw it.
Yeah.
Yes, here. So Naveen, based on the particular browser, anyways, our source code from a Visual Studio from a Node.js, it is getting
Mm-hmm.
interacted with either it is a V8 or it's with a Super Monkey or sorry, Spider Monkey. So
Hmm.
Node.js is by default coming with a V8 engine, right? So how V8
Mm-hmm.
engine in Node.js is playing its role.
Sorry, I didn't get your question.
Okay. So what I'm saying is Node.js is coming by default with a V8 engine, right?
Correct.
Yeah.
No, no,
So
no.
whenever
You are saying reverse. V8 engine is coming in the Node.js.
yeah, V8 is coming in a Node.js. Okay.
Hmm.
So Chrome browser, whenever we are interacting with the
Okay, so
Chrome
let me.
browser, V8
Okay, I
engine is
got your
getting
question.
yeah,
So
yeah.
this is a
How this V8
Node.js we have installed in my local. Today we have
yes,
installed it. We have checked the version
correct.
22.
Yes.
And this is a JavaScript code that we are writing. Let's see anything. Let's see playwright code that we are writing or normal Java code or JavaScript code we are writing. So Node.js will execute this particular code, right? And then after
Yeah.
that, if I'm writing any playwright code, because with the playwright I have to interact with the browser. I'm sending, okay, I'm executing it. Okay, perfect. It looks perfectly fine. Then I'm sending a request to my playwright server. This is a playwright server, let's see, running. which will help me to interact with the browser. Now this entire request will be sent to the server, will be sent to the browser. But browser will use what? Browser will use its own V8 engine or Node V8 engine. Browser will use its own V8 engine, right?
Browser engine.
Exactly. So that this V8 engine
Yes,
will help
correct.
me to execute these program, whatever that code that we have written. V8 engine will help me to find the XPath, find the CSS selector, find other things, and then scroll up, scroll down, right?
Yeah.
So V8 engine will help me to do that. So from our side,
Yes.
we are writing the JavaScript code. Okay, please scroll. And then this entire code will be understood by this particular V8 engine. It will help me to scroll up and scroll down over here.
Yeah.
Okay.
But then why, how this V8 engine in Node.js is playing its role? I'm asking.
Because this Node.js is obviously has to execute this entire JS also, right? We cannot say this raw JS to the browser, right? Let's say, for example, you have written some calculation here. In your Playwright code also, let's say I'm doing some calculation. I'm calculating the billing and all those things. Who will execute that? Browser will not execute. Browser is responsible only for the browser related work. V8 engine inside the browsers is responsible only for the browser related work. But let's say you are getting something here. You are getting the title, you are appending some string here, you are doing some calculation here. Who will do this? This Node.js V8 engine will do it, right? Okay. So this V8 engine, SpiderMonkey, responsible only for browser related activities. And this is related for the local activities that we are doing in our system, in our code.
Okay. Yeah. And another question is that, Navin, so when applications are getting developed in multiple languages like Java and even .NET also. So how this JavaScript by using a Playwright remains the same,
Later
right?
on, yes. So as a Java developer, if I'm writing Selenium Java code also, everything will be, when it reaches to the browser, everything will be converted into the JavaScript kind of thing, and then JavaScript will be executed on the browser. Languages are given to us for our user-friendly point of view. I don't understand JavaScript. I want to write in Python. Fine. I'm writing the code with Selenium Python. I'm developing something in Selenium with Python. But end of the day, everything will be executed with the JavaScript only on the browser, because browser does not understand Python. Browser does not understand Java. Okay.
Okay. Yeah. Got it. Yeah. Thanks, Navin.
Yeah, hi Navin.
Hmm.
So can you please explain about that 80-20 split of the types